Section 1.5 and 1.6 is combined into a single assignment, and it talks about mixture problems. You're mixing two things that have different values. For us, one value might be that you have an account that earns 10% interest and then another account that earns 6% interest. And what you want is to diversify between these two accounts. You don't want to put all your money in this riskier investment. Smaller interest rate would be a safer investment. If you have a total of $100,000 to invest, let's suppose that our allocation will be that we'll put $80,000 into the 6% account and $20,000 into the riskier 10% account. If we do that, how much total interest will we earn? Well, our interest would be 6% of the money that I put in there, 80,000 plus 10% times the money that I invested at 10%. And then that will make $4,800 plus $2,000. That's a total of $6,800. And just for the record, that's a 6.8% return overall on average for your $100,000 investment. Notice that if you had a scale, you went from 6% to 10%, and you made like a graph, 6, 7, 8, 9, 10. Right in the middle is 8%. We didn't get an average of like right in the middle of the 6 and the 10%. Our 6.8% return is way over here. And that's because we weighted so much more money at 6%. We put 4 times as much money at 6% than we did in the 10% account. If these had been 50,000 and 50,000, if they had been equally weighted, then the overall average would have been right in the middle at 8%. But the more money we weight toward 6%, the more that the overall average will tip toward that amount. Okay, now let's go back and have $100,000 to invest, but this time we have a different kind of goal. So if that's my goal, then the question is, how do I allocate? So I will introduce two variables. I'll have X be the dollars that I invested at the 10% account, and I'll have Y be the dollars that I invest in the 6% account. My first equation will talk about the total dollars invested. My second equation will talk about the total interest earned. So the total money invested is $100,000. And in terms of my variables, that would be the dollars at 10% combined with the dollars at 6%. So that would be X plus Y. Total interest earned, $7,500. This one is a little bit more complicated, but that interest comes from the money at 10%, would be 10% interest times however much money I put there, X, plus, and then I get 6% in the safer account. That interest will be 6% times Y. That has to add up to $7,500. Rearranging it a little bit just so it looks more familiar from how you've seen it in math. X plus Y is $100,000, and then 0.10X plus 0.06Y has to total $7,500. That makes a system of two equations and two unknowns. You can solve it with substitution or with elimination. Substitution works best on these problems, especially when there's one equation with really simple variables. So take this equation and solve for one of the variables. So I'm going to isolate the Y, get it by itself. To do that, I'll have to take away X from both sides. And that will give me Y equals, the X will cancel, 100,000, take away X. And now that I have the Y isolated, wherever I see Y in the other equation, I can take 100,000 minus X and substitute it in its place. So my second equation becomes 0.10X plus 0.06 times, take out the Y, put in 100,000 minus X. Carry on with the rest of your equation, equals 7,500. I now have a single equation with only one letter, and that is solvable with algebra. So 0.10x plus distribute 6,000 minus 0.06x equals 7,500. Combine like terms. 0.10x minus 0.06x is 0.04x. Take the 6,000 and subtract it from both sides, and you get 1,500. Divide by 0.04, divide by 0.04, x equals 37,500. Okay, $37,500. And was that invested at 10% or 6%? And how do I know? Well, I know because this is the value for x, and I named x. I made x the name of the 10% account. So 37,500 invested at 10%. Then how much would be at 6%? Well, the rest of the money. So to find y, you could use this formula. It'd be the total investment of 100,000, take away however much was in the other account. So 100,000 minus 37,500 equals 62,500. So given my goal of $7,500 of interest, how do I allocate the funds? I would invest $37,500 at 10% and $62,500 at 6%. Let's look at the WebAssign homework. Okay, in this problem, we're going to be borrowing money, and we have two sources, the bank and life insurance. The interest on the bank loan is 10%, and the interest on the insurance loan is 12%. If the total amount borrowed is $100,000 and his total yearly interest payment was $10,700, how much did he borrow from the bank? Let's make the 10% bank loan be X and the 12% insurance loan be Y, and that's the dollars that I borrowed from each. I'm going to have two equations. One will talk about the total that was borrowed, and the other will talk about the total interest. Okay, the total borrowed. X dollars borrowed from the bank plus Y dollars borrowed from insurance has to equal $100,000. And then the interest that I will owe on those loans, I'm going to pay 10% interest on X dollars, plus I'll pay 12% interest on Y dollars. And I know that that turned out to be 10,700. So now I can form a system of equations. I need to substitute, so I'll go to the easier equation and isolate one of the variables. I'll just isolate y. So I'll subtract x and subtract x. Y would be 100,000. Take away x, and then take that expression, plug it into the other equation in place of y. Second equation becomes 0.10x plus 0.12 times y is 100,000. Take away x equals 10,700. Now that I only have one variable, I can go ahead and solve the equation. 0.10x plus distribute 12,000 minus 0.12x equals 10,700. Combine the x's, that gives me negative 0.02x equals, I'll have to subtract 12,000 from both sides, negative 1,300. And then divide by negative 0.02, divide by negative 0.02, and x has a value of $65,000. Okay, that's $65,000 that was borrowed from the bank. How do I know that was from the bank? Because I'm solving for x, and I named x the bank loan. And then go to WebAssign. Is that what they wanted? Yes, they wanted borrowed from the bank. That'd be $65,000. And just for the record, suppose they wanted to know how much was borrowed from insurance, then I could figure out why, because it's the rest of the money. So $100,000 total. Take away the $65,000 that now I know I got from the bank would be $35,000 from the insurance. Next, we'll look at problem number 2. This is another mixture problem, except this time instead of mixing two accounts with different interest rates, we're mixing two different products with different price points. So we're trying to hit a different a price point in between the 280 and the 530. We want to create a mix, and we want it to sell for $3.60 per pound. And we want to have 100 pounds of the mix when we're done. And the question is, how many pounds of each should we use so that we get 100 pounds of the mix, and that mix will sell for $3.60. For our purposes in this problem, we want the cost of the materials that we use, in this case the peanuts and cashews, to equal the expected revenue that we're going to get from selling it. I will let X stand for the pounds of peanuts that I use in the mix, and I'll let Y stand for the pounds of cashews. Then I'm going to have two equations, one that will talk about the total pounds and one that will talk about the total money spent and received. Okay, my first equation is pretty straightforward. The pounds of peanuts, X, plus the pounds of cashews, Y, should equal the total pounds of the mix when I'm done, which would be 100. Then the money that is spent on the peanuts, I'm going to spend $2.80 per pound, and I will have X pounds. Plus, and then for the cashews, it'll be $5.30 per pound, and I'm going to use Y pounds of those. So this is now a dollars equation, where my first one was a pounds equation. I've got the cost on the left-hand side. I want the revenue on the right-hand side. So from my revenue, I will have a product that's going to sell for $3.60, and I will have 100 pounds of it to sell. This setup is somewhat different from the interest rate accounts problems. The sum of the parts will equal the whole. And in the parts, we have price times pounds for the peanuts, and then price times pounds for the cashews. And then we have price times pounds for the final mix. Okay, let's solve it now. I have a system of two equations. X plus Y is 100, and 2.8x plus 5.3y is 3.6 times 100 would be 360. I'll use my first equation and isolate a variable, so I'll isolate y by subtracting x from both sides. That will give me y equals 100 minus x. And then I will take the 100 minus x and I'll substitute it in for y in the other equation. 2.8x plus 5.3y, 5.3, insert 100 minus x in place of y, will be 360. Clean it up and solve. 2.8x plus 530 minus 5.3x is 360. I will combine my x terms. Gives me negative 2.5x. Subtract 530, subtract 530. Negative 170. And then divide. I got x equals 68. And then the question is 68 what? 68 of whatever x was used for pounds of peanuts. So 68 pounds of peanuts in my mix. And then for the pounds of cashews, y is right here. The 100 pounds minus whatever x was, 68. So the other 32 pounds in the mix would have to be pounds of cashews. So web assign pounds of peanuts, 68, pounds of cashews, 32. On problem number 5, suppose a computer manufacturer has a total cost function and then they hand you a cost function. Don't get used to that. Later on, we'll have to create that ourselves. But for now, just be grateful that you know the cost function was 78x plus 3,600. And the total revenue function was 378x. Given that information, what is the equation of the profit function? So profit, we know that profit is revenue minus cost. So I'll fill in the revenue function, which is 378x. Take away, make sure that since the cost function has two terms, you need parentheses around this. 78x plus 3,600. Distribute the negative through. 378x minus 78x minus 3,600. And simplify to get my profit function is 300x minus 3,600. Okay, in WebAssign, notice that they already have the P of X and the equal sign. So I just need to put the expression 300x minus 3,600. What is the profit on 336 items? Okay, that 336, that's a value for X. So I plug 336 into the profit function and work it through. This now becomes just a calculator question. I got 97,200. And then part C, how many items must be sold to avoid losing money? So losing money, that means your profit is negative. So again, most people don't say you have a negative profit, they say you have a loss. But in math class, we say, no, your profit was negative. So to avoid losing money, you want your profit to be bigger than zero. I'll just look for when it's equal to zero, and then I know I have to do better than that. So now that I have a profit function of 300x minus 3,600, I could set that equal to zero and back solve to find the x. So add 3,600 to both sides. 300x would be 3,600 and divide. It looks like X would have to be 12. 12 items sold before the profit hits zero, and that's your break-even point, where your profit stops being negative and is on the verge of becoming positive. Number 10, we have a home improvement outlet, and they have two data points for the relationship between the number of framing studs that they sell and what their price is. So 2,100 when the price is $337, but the demand increases to 3,500 when the price is $295 each. Suppose that the demand function is linear. That's huge. That means that the demand can be in the form of an mx plus b. Write its equation. Okay, at heart, in a mathematical sense, I am trying to write the equation of a line, and that line is the demand function. To write the equation of a line, I need two pieces of information. I need a slope, and I need 1 point. Well, first I have to get some points, so I need to take the data and organize it into points. And generally, we put units in the x-coordinate, and then price will be in the y-coordinate. So for the units, I'll call that Q. They want Q for quantity, and price they want called P. 2,100 is a quantity when the price is 3.37, and then 3,500 quantity when the price drops to $295. Okay, with those 2 points, I can create a slope. Y2 would be 295 minus Y1 is 337 over X2, 3,500 minus X1, 2,100. Negative 0.42 2 in the numerator over 1400. This will simplify down. It's not great practice to have a decimal as part of a fraction. So dividing that out, it becomes negative 0.0003. That is my slope. And then take either point. It won't matter which one you choose. Now that you have a slope and you have a point, we can use y minus y1 is slope times x minus x1. Except I don't actually have y's and x's. I have p minus p1 is slope times q minus q1, because WebAssign is going to want me to enter it with p's and q's. So p, take away. The p coordinate of the point I chose is 2.95 equals slope, plug in 0.0003 times q minus q1 is 3,500. And simplify, distribute. Distributing the negative on the second term will make it positive. That's 1.05. And then add 295 to both sides. I have p equals negative 0.0003q plus, that makes 2, 3, 4. They wanted an equation, so I need the equal sign, and make sure that you use p's and q's. Don't use x's and y's. Okay, go back and look through your homework on WebAssign, do everything you can, and I will see you in class.